Hello students, welcome to the next lecture on the numerical analysis. Today we will discuss about the fixed point equation method. We will solve the various 10 to 12 examples in this lecture so that you can understand this concept very well. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the various videos on the numerical analysis. You may see that there is a playlist of the numerical analysis where we have started the bisection method and their respective MATLAB code, Regula-Falsi method and their MATLAB code, fixed point equation method, that is the first lecture on the fixed point equation where you can find the convergence condition, secant method, Newton Gauss elimination and many more. All about this are the theory as well as MATLAB code. So let's start with this video. So as we have discussed in our last videos that how you can find the root of the equation, there are so many methods are there and some of them are listed as here. So as I show you, these three methods we already covered in our last lecture. We already covered the theory lecture as well as the MATLAB code. So you may watch this playlist of the numerical analysis on its MATLAB code. Now in this lecture we will see how you can find the root of the equation f of x is 0 by using fixed point equation method. So what is the purpose of this fixed point equation? The purpose is very simple. You have to apply the concept of fixed point into this equation. What is the concept of the fixed point is? We have to transform this equation f of x is 0 into x of gx. But the question arises is, what is the f x is equal to gx? What does it means? What does it means? So this is basically a fixed point. What is the formal definition of the fixed point is? Any point x is said to be the fixed point of the function g if g of x is equal to x. Or what is the meaning of that? If you draw the graph of y is equal to gx on the xy plane, and if you draw the line of y is equal to x, the point of intersection of this line y is equal to x and y is equal to gx is called as the fixed point. That's a formal definition of the fixed point. Remember, the fixed point may or may not be a unique. May not be unique. So it means it may have the infinitely many fixed points. It may have a unique point or it may have the no fixed point. For example, if I consider the function of this, so clearly says if I draw the graph of y is equal to 2 plus x, it is just like say parabola. And if I draw the graph of y is equal to x, you can clearly says if I find the point of intersection, you will get this expression. And clearly says x is equal to 2 satisfied this equation. Why? Because 2 is 2 plus 2 clearly satisfied. Therefore 2x is equal to 2 is my fixed point. On the other hand, if I consider the graph of y is equal to x plus 1 and if I draw the graph of y is equal to x, so then clearly says there is no point of the x which satisfied this equation. So clearly says 0 is equal to 1, which is not possible. Hence there is no fixed point. If you want to draw the graph of this, look at that, this is a line of y is equal to x plus 1, and if you want to draw the graph of y is equal to x, clearly says both the lines are my parallel. Fine, you can see the slope of the two equations are same, so you can say it's a parallel. So once they are parallel, they can never intersect. Once they are never intersect, it means there is no fixed point. So this is an example where you have the unique fixed point, where you have the no fixed point or infinitely many fixed points. Based on this fixed point, we can transform this equation into this equation x of gx. But the question arises is how we can transform the equation into x of gx. So there are so many ways. It is not always a unique way. For example, like here, if you look about that, if I take x square common from this, then you can simply write this equation as here, which is my first equation. If I find the value of the x from here, you can see x square is 2 minus x cube. So what is my x? This is 2 minus x cube, which is my second expression. Similarly, I can find x from here, that's a 2 minus x square of cube root. So you can see each equation is written in the form of x of gx and many more are. So clearly say it is not a unique. Similarly, if you consider another example like of this, again you can write the equation in this form or in this form or in this form. So again you can see the representation of the gx is not unique. The question arises is how we can choose the suitable gx so that the convergence will guarantee. So that I already explained you, any of the iterative method is convergent when this condition hold. So it means whenever you want to rewrite the equation f of x is 0 into this form, you just need to check whether this condition is satisfied or not. Now how you can solve the finding the root of the equation by using the fixed point. Let f be the any continuous function and I be the interval in which root lies. If the interval is already given to you, then it's fine. If it is not given to you, then we can apply the intermediate value theorem. What is the intermediate value theorem is? You have to find the function value at a, you have to find the function value at b, and you can show the product of this function value must be less than 0, then the root is lies between a and b. If interval is not given to you, if it is given to you, then it's fine. Then we have defined the 3-step approach. The step number 1 is we can transform the equation into x of gx where g satisfied this property. Then we can choose any initial point in this interval. You can choose any initial point like say 1.4, 1.5, 2.3 and anyone which satisfied this equation, and compute the value of x1 like of gx naught. You can compute the value of x2 as g of x1 and so on. And then you can check the stopping criteria, that is whether the relative or absolute error. So this is my absolute error. If it is less than of my accuracy may be 10 to the power minus 4, 4 decimal places, 5 decimal places, then you can say xk is my root. Otherwise you can go to the step number 1. You can change the error either as the absolute error or the relative error. So I will explain you the 10 to 12 examples so that you can easily understand this lecture very well. Now first of all you have to apply the iteration methods, which is also called as the fixed point iteration method. Now if you read the statement, clearly says the initial point is given to you. This is the initial point which is already given to you. Then there is no need to find the interval a comma b. If the initial point is not given to you, then we can find the firstly interval. Now you can compare this equation with x of gx. Then clearly says this is my here. Now you can see whether this equation is satisfied or not. You can check the derivative is strictly less than 1 or not. Remember, this is a strictly less than 1. So you can find the derivative. What is the derivative of the cos x? It is strictly less than of here, and you can see this 0.21 mode is nothing but my here, which is my less than of 1. So it means the fixed point iteration method is applicable. So how you can applicable? You can start with the x naught. X naught is given to you as 1.2. Then you can find the value of the x1 as g of x naught. What is my g? This is my g. Now remember, when you substitute this value here, it is sine of 0.5 plus 0.12. Now remember, this value, which is nothing but my 0.62, you have to compute this value in the radian. Remember, when you are using the calculator, you can set your values of the sine and cosine, either the sine, any of the trigonometric functions, sine, cosine, tangent, secant, you have to set as a radian. So once you substitute this value, you can compute this, you will get as here. Now you can find the value of the x2, which is g of x1. That is, I can substitute this value at here, and then you can find this value. Now clearly says that only the 2 decimal places. Now how many decimal places you need? It is nothing is given to you, so you have to compute up to the 4 decimal places. But here you can see only the 2 decimal match. You can find the x3. Once you can find that, you can see the 4 decimal places match. Fine. Once the 4 decimal places, you can find the x4 as well. You can see x3 and x4 are same. So the desired root is my here is the required answer. Look at the second example. The equation x of this can be written in the two ways. Which of these is applicable for the fixed point equation? Very simple. We can say this is applicable only when this condition hold. So let's start with the first one. This is my g of x. We can find the derivative, which is here. Now for the convergence, I can substitute this value here. What is the meaning of that? When it will be less than 0. So first of all, it is a root of this. Fine. So it means this value must be greater than 0. Otherwise, it will be a complex number. So you can see 5x minus 2 must be less than of 1. So can you find the value of the x from here? It must be less than 1. So it means 5x must be less than of 3 and x must be less than of 0.6. So since we are looking about initial point is my 0.5, so it satisfied this property because 0.5 is less than 0.6. So you can see the equation method will converge in the neighborhood of 0.1. But remember, if you take x naught is my 0.8, then it is not satisfied. So we can say this will converge only in the neighborhood of less than of 0.6. But if I take x naught is 0.58, then it will not be converged. X naught 1.2, it will not be converged. Similarly, if you look about the second example, second case, then this is my gx. You can see here, you can find the derivative. What is a cos x? It is always be less than of 1 divided by 5. So since 1 over 5 is less than 1 for all x, fine, this is for all x. So what is the meaning of that? Either you can take x naught is my 0.5, either you can take x naught as my 1.3, either you can take x naught is my 4.3. In all these cases, your equation method will converge definitely. So this is the best choice if in order to find the fixed point equations. Okay, look at this next one. So clearly says in this example, the initial point is not given. Fine. So if initial point is not given, then we firstly find the value of interval a comma b. So we can transform this equation here, but before that we need to find the interval a comma b. So how you can find? So clearly says if I start from the f3, which is a negative, you can find that f of 1 which is also less than 0, f of 2 which is also less than 0, f of 3 which is also less than 0. You can find the f of 4 which is greater than 0. So it means the root is lies between 3 and 4. That means my interval is 3 comma 4. Then your target is to convert this fx into x of gx. So the one way is you can find the value of the x like of this manner. Fine. Otherwise you can also find the value of x of 10 raised to power of this, because it's a base of 10. You can write this and many more. So out of that you will check whether g dash of x is less than 1 or not. So firstly I can check for here. What is the g dash of x? This is my gx. If you find the derivative, it will be here. So clearly says it will be 1 by 2 is outside. What is the log of 10 of e? I can return this value as log of e divided by log of 10. So what is the log of e? You can see the value of log 10 is come to be here. So this number is my 0.4343 divided by 2 whenever x lies between 3 comma 4. So 1 over x will lies between 1 over 4, 1 over 3. So this number is also less than 1. This number is also less than 1. The product is also less than 1 for all x in here. So therefore the equation method is applicable. So now you can choose x naught any value in between 3 and 4. Remember, any value. You may choose 3.6, you may choose 3.5, you may choose 3.0, you may choose 3.01 and so on. It's on your choice. So let's say I can choose x naught is 3.6. Best way is you can choose the in the near point of this. I can substitute this value in this g of x, which is come to be here. Then I can find the value of the x2, because we need up to the 4 decimal places. You can see I need a 4 decimal places. It is not correct. We can find the value of the x3, which is x of 2. We can substitute this value at here and then we can find that. So clearly says up to the 4 decimal places it match. So we can say x3 and x4 are same up to the 4 decimal places. So the desired root is my here. Look at the another example. Let a be the any positive value. So a must be greater than 0 such that g of x is my here. Show that if this converges to the non-zero limit, then the limit is 1 over a. So what is the fixed point equation here? G of x is given to you my this. Fine. So what is the meaning of that? If the fixed point converges to the non-zero limit, so let's say limit is my alpha. What is the meaning of this? Xn plus 1 is converges to the alpha. So I can take this limit. It will be alpha of g of alpha. Fine. So what is the g of alpha? I can substitute here. So what is the limit of this? I can substitute this value. G of x is my here. What is the limit is? It will be 2 alpha minus a alpha square. So can you find the value of the a from here? It is alpha is a alpha square. Fine. So what is the meaning of that? Or you can say alpha is a alpha square. So since it means, what is the meaning of that? A is my 0, or sorry, you have to find the value of alpha. So what is the alpha is? I can take alpha as a common. So 1 minus a alpha is 0. So alpha either 0 or 1 over a. Fine. But you can see a is my given positive number and the given convergence to the non-zero limit. So what is the value of the alpha? This case will be cancelled out. The only non-zero number will be my 1 over a is the required answer. Find the real root of this by using the equation method, which is also called as the fixed point equation method. Now you can see how many decimal places you needed. It is not given to you. So the by default you need to consider as a 4 decimal places. Again, the interval a comma b or the point x naught is not given to you. So you must need to find firstly a comma b interval. And then we can transform the fx of this. So clearly says what is the value of the f1? It is my 1 greater than 0. F of 2, instead of the 2 I can simply say f of 0. What is f of 0? Is minus 1, which is less than 0. They are opposite sign. So therefore root lies between 0 and 1. So I can transform this equation into here. So how many ways? There are so many ways. I can write this equation as 1 minus x cube of 1 by 3. I can write this equation as 1 minus x cube of 1 by 2, or I can write this equation as of 1 plus x here. Then out of these 3 equations you can check which one satisfied this condition. So I think clearly says that 1 over this will satisfy this equation. So I can simply take x as my here. So this is my gx. I can check their derivative. Now what is that? X belongs to my 0 comma 1. My target is to prove this is a less than 1 for all x belongs to the 0 comma 1. So how you can prove that? So now x lies between 0 and 1. So 1 plus x is lies between 1 and 2. So root of this will lies between 1 here, and then if I divide it by 2, it is my 2. So clearly says this number is less than 1, this number is also less than 1. So hence x plus 1, root x plus 1 by 2 is always less than 1. So therefore fixed point equation method work. So it means you can choose any number in between the 0 comma 1. You can choose any number. You may choose as a 0.5, you may choose as a 0.65, you may choose either as a 0.95 and so on. So I can simply take x is my 0.5. Then I can find the value of x1, which is g of x naught. This is my g. I can substitute this value 1 over 0.5 plus 1. So after the calculation you will get this answer. Then I can find the value of the x2, which is g of x1. What is that? This is 1 plus x. X is my 1.6. So I can substitute this value, you will get here. Similarly, since we need up to the 4 decimal places, so they are not matched, so we can find the value of the x3. And since again it is 3 decimal places not matched, you can see here up to the 4 decimal places it matches. So I can say x6 and x7 are same, so the desired root is my here up to the 4 decimal places. Look at this another one. Again, in this case they are talking about the 3 decimal places, but the initial point is not given to you. Fine. So it means again you need to find the interval a comma b, but make sure this is my cos x. You have to set your angle in terms of radii. Fine. Now what is that? What is the f of 0? So cos 0 is 1. This is a 0, so 1 plus 1 2, which is greater than 0. So if I take as a pi by 2, so it is cos pi is 0, it is minus 3 pi by 2 plus 1. So what is that? It is minus 3 over 2 into 3.14 plus 1. Clearly says this will be less than of 0. So it means the root lies between this number. So what is that? It is root lies between here. Fine. Or you can say it is 3.1415 divided by 2. Now you can transform this equation into here. We can find the value of the x either like of this manner, cos x plus 1 over 3, or you can find the value of the x from the cos also. It is cos inverse of 3x minus 1. So based on this you will again check whether the derivative is less than 1 or not. So firstly I can check about here. What is the derivative of this? It is my 1 by 3, because you can see what is the g dash of x? It is minus sin x over 3, and if you take the modulus of this, what is that? It is a minus sin x. So its minus is plus, sin is always less than of the 1 by 3, which is strictly less than of 1. So therefore iteration method is applicable. If for example if this is not greater than 1 for all x, fine, then you can find the value of the x from cos inverse of 3x minus 1, and then you can check about the g dash, check whether it is a less than 1 for all x. Remember the word is for all, this is for all. Then you can choose any value in between them. I can choose as a 0. Then we can find the value of the x1. What is that? Cos 0 is my 1, 1 plus 1 2, 2 divided by 3 is my here. We can find the value of the x2, which come to be here, which is not same as the of the 3 decimal places. Then we can find the x3. x3 is my here. Again they are not same up to the 3 decimal places. We can find the value of the x4, and here you can see up to the 3 decimal places they are matched. So you can see x5 and x6 are same, so my desired root is 0.607 up to the 3 decimal places. Okay, look at this another one. Suggest a value of the c, this value of the c, so that the fixed point iteration method converges at the good rate, given that root 3 is my root. So that's very simple. Let f of x is here. Remember, in this question they are not asking you can find the root. They are not asking you, because root is already given to you. It means there is no need to apply the iteration process like g of x naught, g x2 is equal to g of x1, and so on. There is no need to apply them. What is given to you? The first concept is it is as a good rate. What is the second thing is this is my root. These are the two concepts, and the third concept is convergence. Fine. So when the iteration method will converge, when g dash will be less than of the 1. So this is my iteration formula. It is already given to you that this is my fixed point iteration formula. So what is the meaning of that? This point is nothing but, this f is nothing but my g of x. So what is the condition for the convergence? We can see f dash is my here. So I can return this number as this number also. Fine. I can find the value of the f dash. What is the value of the f dash of x? It is 1 plus 2cx. So I can substitute the value of the 1 plus 2cx as here. Another condition is given to you. It is convergent at a good rate. When anything is convergent at the good rate, when the derivative will be 0. Fine, because the slope will be 0. So you can see the convergence will be high when the derivative, where a is my root of the equation, the root is my root 3. So that is a is my root 3. So if I take that derivative, and then because this is the derivative, so I can substitute this value 2c, a is my 0, where a is my root 3. So I can find the value of the c from here. So what is the value of the c is my this. So this is the value. Fine. Or you can say, because I have to substitute this value at point this also, this is the equality, but we need a strictly less than. So what is that value? I can reduce this number as root 3 divided by 6, means 1.732 divided by 6. It is 0.6 to the 12. So 53, 8 6 are 48. So it's a 52, and then 8 6 are 48, 0.288 minus of the 0.288. So I can choose any number which is smaller than of 0.288, which is less than of the 0.25. So the best way is you can choose the number as, either you can choose any number which is less than of this. So I can choose c is minus 0.25, which is a proper integer, a proper decimal number. So that will give you the convergence at the good rate. You can choose any number which satisfies this equation. This must be less than of 0.15. You can choose the 0.15 as well. So that's on your choice. Because they are asking about the suggested value of the c. So any number which is less than of this is the good choice. Okay, now look at this. Apply the fixed point method. Now you can see that the root is already, the interval is already given to you. It means there is no need to find whether f of a and f of b is less than, greater than, there is no need to find. So the purpose is, you have to firstly write f of x is my, what is my f of x? X e raised to power x minus 1, 0. Your target is to convert this equation into x of gx. So clearly says there are the two ways. X ex minus 1 is 0. The first way is you can find the value of the x like here. Second way is you can find the value of e raised to power x is 1 over x, and then you can say x is my ln or log of 1 by x. There are the two ways. So let's see, firstly I can check about here. If this is my gx and then this is my gx. So we will check on those both cases where this value will be satisfied. So let's see, first we have discussed about this case. What is the g dash of x? Minus e raised to power minus x. What is the g dash of mod? It is 1 over e raised to power x. Now x is lies between 0 and 1. So this number is always less than of 1. Fine, because this number is nothing but 1 over ex, and it is less than 1 for all x which belongs to the 0, 1. So therefore the equation method is applicable on this gx. Now since the initial point interval is given to you, so you can choose the initial point any number. So the best way I can choose as a 0.5 or 0.56, 0.57, it's on your choice. So then I can choose as x1, which is, what is the gx is e raised to power minus x. So I can say e raised to power minus 0.7. So it comes to be here. So I need again the decimal. How many decimal places? It is not given to you. So we can found up to the 4 decimal places. We can found the x2 and x3. Again the 4 decimal places are not matched. We can found the next two equations. Again they are not matched. We can found the x6 and x7. Again the 3 decimal places are matched only, but we need a 4 decimal places. Now you can find 4. So you can see the 4 decimal places are matched. So therefore the root of the equation is my 4 decimal places is the right answer. Okay, look at the next one. Consider the equation this. Root lies between 4 and 5. So interval is already given to you. can you locate the root? Can you locate the root? How you can decide that? That is a convergence. You only need to check whether this condition satisfied or not. Fine. So if yes, you can find the 5 iteration by taking the initial guess here, and finally you can check their boundary. So that's simple. We can find the g. So there are 2 ways we can find the g. So if I check firstly about here, then g is my this. Find the derivative of the g, which comes to be here. Find the modulus value of this, which comes to be 1 by 4 e of x by 2. Now x is lies between 4 comma 5. Then x by 2 is lies between 2 and 2.5. Fine. Then e raised to power x by 2, if you take any number in between them, say I can take x is my 2, then e raised to power 2 is my greater than of 1, or e raised to power 2 divided by 4 is my greater than 1. So this number is my greater than 1 for all x in here. So what is the meaning of that? It is not convergent. If it is not convergent, then the fixed point iteration method is not applicable. So you are unable to locate the root of the equation. So the fixed point equation failed to converge in the root of this. Then we can find the value of the g from the second case. If I take this is my g, what is my derivative of this? What is my g? ln derivative is my 4x square into derivative of 4x is 8x. So the answer is 2 over x. Fine. Now clearly say this is my positive. Now whenever x lies between 4 comma 5, fine, what is the 1 over x? It lies between 1 over 5 comma 1 over 4, fine, and then 2 over x is lies between 2 over 5 and 1 over 2, and both the numbers are less than of 1. So therefore we can see mod of g, which is mod of 2 by x, which is always less than 1 for all x lies in 4 comma 5. So therefore yes, you can find the root of this, but for this you have to take this as the fixed point iteration scheme. Fine, clear? The first part is clear. Now if yes, it is yes by case of this, then we can take this is my g, and then initial guess is given to you as a 4.5, then my g is my here. So I can need to find the 5 iterations. Why 5 iteration? Because it is given to you as the 5 iterations, and then we have to find the error. So x1 is, I can substitute the value of this as here, you will get this expression. Then x2, I can substitute this value at here, you will get as this expression, this value. I can substitute this value at here, again you will get this value. Similarly x4 and x. The last part is you have to find the error bound. This is the formula for the error bound, and you have to find the lambda. So lambda is nothing but the maximum of the g dash. So what is my g dash? You can see from here it is my 2 by x. Now since we have to find the maximum value on this closed interval, fine. So how you can find the maximum of this? So we all know whenever there is a closed interval, then the maximum will occur. If I say you have to find the maximum of the fx where x belongs to the closed interval a comma b, then the maximum is occurring either at the f of a, either occurring at the f of b, or is occurring at the critical point. What is the meaning of the critical point? You have to take that derivative, which is 0. Now you need to find the maximum of 2 by x. So firstly I can take the critical point. So what is the second derivative of this is minus 2 by x square, which is not 0. Fine, because it is 0 only when x is infinity, which is not lies. So it means in this case critical point is not there. Then we have to find the maximum value at the 4 and 5. So what is my g dash of 4? It is 2 by 4. What is my g dash of 5? It's a 2 over 5. So this is my 0.5, this is my 0.4. So the maximum value is at 0.5. So therefore lambda is my 0.5. So you can write like here. So see, g dash is my 4 by x. Sorry, it's a 2 by x. G dash is my 2 by x. So g dash is monotonically decreasing. Why? Because if you take the double derivative, it is my 2 by x square. So it is a less than of 0. Otherwise there is no need. You can simply apply this method. Find the derivative at the 4 and here like this. So clearly say the maximum is occurring at the end points or at the critical point, but the critical point is not existence in this. So the maximum value of the lambda is my 0.5. I can substitute this value here. This is the 0.5 x1. This is my x1. x0 is my here. N, how many steps you have taken as a 5. So n is my 5. x1 is my this. x0 is my this. After the calculation you will get as the error bound after the 5 iteration is my here. Okay, look at the another one. Apply the fixed point equation. Find the smallest and the second smallest of this equation, tan x of 4x. Very simple. Interval is not given to you. Fine. So firstly you can find the interval. So f pi by 4 is less than 0 because pi by 4 is my 1. It is my pi less than 0 and here. So root lies between pi by 4 and pi. Remember, this is the value of the tan x. So tan x is positive in the first quadrant or in the third quadrant. It means you need only the positive root either in the first quadrant or in the fourth quadrant. The first quadrant will be 0 to pi by 2. Third quadrant will be pi and 3 pi by 2. Fine. So firstly we can find the first positive root, that is lies in the first quadrant, like of here in the first quadrant. So you can choose the value of the g. I can see g is my x is my tan inverse of this, or you can written as tan x by 4. So clearly says if I take this is my gx, what is my derivative of this? Secant square x over 4. Clearly says when you take the modulus of this, it will be greater than of 1. So it means this is not applicable. So we can find the value of this. What is the derivative? It is always less than 1. So we can apply the fixed point equation, and that means that's the first quadrant. You can choose any number in between 0 to pi by 2 because the first quadrant is here. So what is the pi is 3.1415 divided by 2. So that means 0, 1.57075. Fine. You can choose any number in between them. So I can choose 1.5. Then find the value of the x1, x2, x3. Again you can see nothing is given to you. Sorry, 4 decimal places. So they are not matching. We can find the x4 and x5. Now you can see the 4 decimal places are matched. Fine. So it means your first smallest positive root is my here, lies in the first quadrant. We can find for the second quadrant, second root is lies in the third quadrant. So third quadrant is lies between pi and 3 pi by 2. So I can written this number as pi plus, that means lies in the third quadrant. Then again we can choose x0 is my say 4.5. We can find the value of x1, x2, x3. You can see the 4 decimal places are matched. So you get the second smallest root as my here. If you want to find the third smallest root, then the third is again lies in the first quadrant. Then instead of the pi, you can write as a 2 pi and so. So you can find as many positive roots from this equation. Okay, look at the one more example. Alpha and beta are the root of this. Show that the equation scheme will converge near the alpha if this hold and this when this holds. You can see this is given to you. Can you find the value of the x from here? Because in order to apply the fixed point equation method, how you can find the value of the x? I can say minus ax minus b. This implies x will be minus x. I can take as a positive divided by x. Fine. Second is I can take x as a common from the first two, which will be minus b, and x can be written as minus b over x plus a. Now if I take this is my g, if I apply this condition, definitely it will depend on the a and b. Similarly for here. So you can see these are my two equations. This is my first equation, this is my second equation. Now alpha and beta are the root of the equation, so the sum of the roots and the product of the roots are given to you. Now for the first case, when it will be convergent? Fixed point will be convergent only when these conditions hold about the point alpha. So we can substitute this value of alpha here, which is my here. Now since we need the answer in terms of alpha and beta, so we can see this number is greater than of the b. I can substitute the value of the b at here. Fine. So what is the value of the b is mod alpha mod beta. You can see one alpha will be cancelled and the equation will be, this is my equation. So it means this will be convergent only when this condition holds. Similarly, you can try for the second part. We can take as a g, we can find the derivatives and we can substitute here. I can write this expression in terms of this. Since I need the value in terms of the alpha and beta, I can substitute the value of the a here. What is my alpha plus a? It is minus beta. So minus beta mod square, it will be my mod of this. I can substitute the value of the b. B is nothing but mod alpha mod of beta. So I can write here. So clearly says again the 1 beta will be cancelled out. So it will be mod of beta will be greater than of mod of alpha. Or you can see mod of alpha is less than of mod beta. Look at the last example. Consider, show that the following rearrangement of the equation does not give a convergent solution about the 1. It means, what is that? It means you have this equation which is 0, which is nothing but f of x is 0. You can transform this equation into x of gx, where x is my here. Like you can find the value of the x from here. What will be 20 minus 6x square? Sorry, it will be the minus. It will be the minus x cube divided by 10, and then show it is not convergent. So what is the convergence condition? We need to check this condition. We can write this equation here and then we can find the derivative. Fine. We can this will be, I think, negative. It will be my, okay, but it is already given to you that this is my condition. So now you can check at 1. So you can see what is the value at 1. It will be 3 minus, sorry, it's a 1. So 3 minus 12 by 10. It will be minus 9 by 10. So it is a 0.9. So I think it is a minus. So it is a negative. It will be my, if you take the derivative, is a negative. So it's a minus 15. So it is my minus 1.5. So clearly says the absolute value is less than of absolute value, because you can see what is the g dash of 1. It is my negative. So it is my minus 1.5. So if you take the modulus value which is greater than of 1, hence the sequence of this fixed point equation does not converge. You may find the x from here. You can see x is minus 6x square minus 10x plus 20 of 1 by 3. Then you can check about whether this condition hold or not. You can find the x from here and so on. You can find it accordingly. So I hope you can simply learn the tricks and the easiest way for solving this fixed point equation method. We will see the next lecture on the Newton-Raphson method. We will see their convergence and their examples. Till then, I request you can share, like and comment on this video. Best of luck, students. Happy learning.